Okay, so let's read part C together. On what open intervals, by the way, I think I said this on Thursday's video as well. Whatever intervals you come up with, then make sure you leave them as open intervals if they're going to be so clear about it. On what open intervals, if any, is the graph of G concave up? Justify your answer. So this is a classic first derivative test sentence that we've done a lot since chapter 5. All right, so if I want to know about G being concave up, I'm thinking about the second derivative of G. Okay, so the second derivative of G then is going to be the first derivative of F. Okay, that's the first thing I need to know. So the first derivative of F, the way I know information about F prime is by looking at the slopes of the f of x graph. So I'm going to use the graph here in a second to think about the slopes here and make myself a G double prime second derivative number line test. Okay, so I'm going to need the graph in front of me. The first thing I can see here is starting at -5, ending at -2, the slopes are positive. Okay, and then at -2, the slope does not exist because there's a cusp at the graph. And then from x equals -2 to x equals 0, now the function is decreasing, so the slopes are negative. And at x equals 0, there's another cusp, so the slope does not exist. From 0 to, what's this, 1, 2, 3? From 0 to 3, the slope is going up again. It's an increasing part of the graph, so the slope is positive. And then here at 1, 2, 3, 3, again, does not exist because there's a cusp there. The slope is 0 from, what is this, 3 to 5. So 0 slope, it's constant. Okay, all we care about for this is where f prime of x is greater than 0, because that's where g prime of x will be greater than 0. So on that open interval that started at -5, because that was a closed interval, -5 to 2, we've got a positive second derivative, and 0 to 3. So now we're ready to write our justification sentences. On the open interval from -5 to -2, and on the open interval from 0 to 3, g prime of x is positive, which is f prime of x also positive. So g of x is concave up, on those intervals. A lot of people did this problem correctly, but a lot of people still really needed to write out these specific statements. Really think about what G double prime is, okay? I really started thinking about my assumption here. The derivative of G is f, so the second derivative of G has to be f prime. And then remembering to think about the slopes increasing and decreasing on this graph to help you answer that.